हरिः कर्ता।
Yes. So Prasad's theoretical learning regarding a priori algorithm is done. Now it's time to put this theoretical knowledge into practice. So that's what Prasad is going to do. So now he is going to work on his data set. So he has a huge amount of data set for 2 years. From for 2 years transactions he has, so on top of that data he's going to work, and he's going to find out if they buy this product, what product I can recommend. This literally he wants to make a recommendation system. Okay, so let's begin. So as we know, a priori principle is, if an item set is frequent, then all of its subsets must also be frequent. So as we will be building a prior association rule mining recommendation system using a priori algorithm, let's quickly run through the basics of it. So what is association rule mining? What is association rule mining? It is a rule based machine learning technique used to find patterns in data. The a priori algorithm is used while the association rule learning takes place. So a priori is a basket analysis method used to reveal product associations. Okay, and this is how it works. Here Prasad wants to make a recommendation system. So first he will see, okay, this is our customer, so what customer is buying frequently, what are the item sets together is buying frequently. If this one is similar, so this item, okay, next time if he buys this one, so we are going to recommend this to buy. So that's what the recommendation system we are going to make. Okay, so the item set which is buying frequently, from that item set we will find out the pattern, and using that, so next time when he is going to buy this item, so we will recommend the respective item to that customer, and that's what the recommendation system we are going to make. Okay, so let's quickly look into uh, evaluation metrics for association rule mining. Formula for support, confidence, and lift for the association rule: x tends to y. So rule x tends to y. In that case, support is nothing but frequency of x comma y divided by n. N is nothing but total transactions. And we have the confidence. Confidence is equal to frequency of x comma y divided by frequency of x. And lift. Lift is nothing but support divided by support of x times support of y. And that's what is evaluation metrics that we have for the respective association rule. So now how do we proceed? Now how the Prasad proceeds further to execute this and to put this theoretical learnings into practice. The roadmap. Now it's time to look into the roadmap. So Prasad will begin with data acquisition and then data cleaning. Once data has been cleaned, now it's time to explore the data that he has. So it's exploratory data analysis next. Then we will go for the feature engineering. So here mainly you will be preparing the ARL data structure, which is nothing but invoice product matrix. That's what is going to make up in feature engineering. Then model building, extraction of association rules. Then preparing the script of the study, and the final step, which is suggesting the products to users at the cart stage. That's what the step-by-step method that we are going to execute. So what we'll be using, the algorithm is a priori algorithm. So let me put it here. A priori is a basket analysis method used to reveal product associations. Okay, so now let's begin with our action. So in our example, for Prasad case, first he wants to understand what is his business problem, or we can say business problem statement. So let's figure it out. What is business problem statement? Business problem statement. So suggesting products to customers at the basket stage. That's what suggesting or recommending products to customers at the basket stage. That's what is our problem statement. And let's acquire the data first. We will acquire the data. Let's get into the action. We will acquire the data first and we will begin. Okay. So step 1, which is data acquisition. Import and acquire the data. Let's understand regarding our data set which we have in our Excel sheet. So the data set name is online retail 2, and contains the sales of a UK based online retail store between 2009 and 2011, and specifically between 1/12/2009 and 9/12/2011. In between those 2 years we have a data set, so that too we have it in two Excel sheets. And we got a workbook named as online retail 2. So now we have to call this dataset. We have to load this dataset using read Excel method, and we have to use the sheet names also. So it's a very important. So that's the reason I have given you this perspective before going and importing that. Okay, let's import require libraries. So import numpy as np, then from ml extend dot frequent patterns, import a priori and also association rules. Both are done. So now let's execute this and see. Okay, now what's next? Let's move ahead with the next step. Let's do slightest modifications with respect to the calling data frame, so that what we the data set we are handling, so with the data set we won't be facing any issue. Okay, so the next step is so the here we want to adjust display settings for rows and columns. We want to adjust the display setting for rows and columns when working with pandas data frames. So that's what. So first what we're gonna write is pd and set option method I'm gonna use. And so display dot max columns, I want to display max columns and none. Okay, next. So here this line sets the maximum number of columns to be displayed in the output. By setting it to none, there is no limit on the number of columns displayed and all columns in the data frame will be shown. And next one, PD, and let me go for the set option. This time display width, display width, and I'm gonna give up 500 and execute it. So this line sets the maximum width of the output display. It determines the number of characters that can be displayed horizontally by setting it to 500. The output will be formatted to fit with a width of 500 characters. Then the next option that we have, that I just want to uh, change the settings for pd dot option. This time it is regarding the expand frame. So display dot expand underscore frame underscore rep. Let me put it false. So here this line controls whether long data frame cells are displayed in their entirety or if they are truncated and shown as a summary. So by setting it to false, the data frame cells will not be expanded and they will be truncated if necessary to fit within the specified display width. And that's what the important settings are required to be done and before loading the data set. So now let's load the data set. So display settings were done in our first step, which is part of that. So 1.1, which is display setting, and now it's time to load. This is 1.2 data loading. Let me 5. Yep. So let me load. So here we have two Excel sheets from one workbook. So based on that, I have to call up. So first, let me say df1 is equal to pd read Excel and workbook name online retail 2 and sheet name, which is year 2009 to 2010. And let me execute and see. It's going to take a lot of time because it has very huge amount of data, lakhs of uh, observations or lakhs of transactions. So that's the reason it's going to take some time. Let's wait for that. So meanwhile, let's write a piece of code for other sheet also. So df2 is equal to, anyway, df1 has been uh, loaded successfully. So read Excel and online and sheet name. Let me directly copy from here. And just change the years from 10 till 11 and execute it. So it's around lakhs of data points we have under these two these two uh, these two Excel sheets, which are part of common Excel workbook, uh, which is named as online retail 2. Okay, let's wait for that. Yep, it's done. So now let's print df1 head. Yep, this is what the df1 head 024. You got the invoice, stock code, and description. Okay, next, let's see, and we'll call up the df. We'll call up df2, and let's see, print df2 head, and this is what. So let's quickly run through our data type. Okay, so what are variables that we have quickly? So if you see here, our first variable is invoice number. So invoice number, the unique number of each transaction, that is the voice, that is the invoice aborted operation if it starts with C. So that's regarding invoice number. So invoice number is nothing but the unique number of each transaction, that is the invoice aborted operation if it starts with C. Then we have the stock code. So stock code is nothing but a product code, unique number of each product. And we have the description. So description, that's the column name. So description column name basically gives the information regarding the product name. Then after that we have a quantity variable or quantity column. So in quantity column, so it consists of number of products, or it expresses how many of the products on the invoices have been sold. Then we have invoice date. So invoice date, it's pretty straightforward. Invoice date and time. Then we have the unit price, very important, unit price. It's product price. It's the product price. And then we have the customer ID. Customer ID. So customer ID is nothing but the unique number. It's a customer unique number. Then we have country. So country name and country where the customer lives. Country where customer lives. So, and this is the analysis regarding the data set. We can call uh, understanding regarding the data set and then variables. We can call this as a data story. It can comes under data story, but anyway. So we have loaded the data, and then we have understood about our uh, we have understood about the variables under that. Okay, so now we got the two worksheets. Now it's time to merge them. So let me say 1.3, which is data merging. So df is equal to df is equal to, we have to merge it. For that, let me say directly, in spite of merging, let me say concatenation, data concatenation directly. Let's make it simple. So dfpd dot concat, and I'm gonna give a list of data frames df1 and df2, and let's ignore the index. So ignore index and true. So let me execute df dot df. Obviously this is concatenated, so df dot head, and here it is. Here is your data with a concatenated data set. And if you want to understand how big is this, df dot size, and it's huge, huge amount of data, huge. 8 lakh, you see that 85 lakh 38,968 rows. So that big is your data set. Anyway, we'll be exploring in detail regarding the data set in exploratory data analysis. Okay, till that we will do one more activity. So let's create a copy of the data was made to avoid reloading the data from the beginning. So let's make a copy of the data was made to avoid reloading the data from the beginning. So df is equal to df underscore dot copy, and let's print df dot head, and here it is, and the copy has been made. Okay, done. Now let's move on to the second step. So step 2, which is data cleaning. So step 2 is data cleaning. Here we will try to find out whether do we have any nulls. If we have a nulls, how to handle the nulls. So df dot is null, and let me put it sum. I want a summary of all, so that's the reason. And you can clearly see we got the customer ID. There are customer ID nulls and description nulls. Okay, so that's what we found. These are the nulls that we have in description as well as customer IDs. Okay, so now let's move on. Of course we'll handle them, and some are in type, and anyway we will handle them soon, not worry about that. So next we'll go to the next step, which is step 3, exploratory data analysis. Okay, so here let's explore the data sets. Let's do the preliminary examination of the data set. So let's say def. For that we will just create a function. So def, so check underscore df. So let me write an parameters for that. So head is equal to 5. Okay, and so print. First, what I want to print, I want to get the shape. Okay, then print data frame dot shape. Okay, and similarly we can get it other attributes regarding the data set. So next one, I want it what I want next is types. So let me say D types. Okay, and next what I want is head. So let me simply say head data frame, head of head. And next I want tail. I want, so let me say tail. Here I can say just tail of head. Next what I want is nulls with respect to that. Of course we have seen that in data cleaning, but still we can do that. I simply say NA, and here I'm gonna say is null, and sum. And the final one, which is quantiles. So in quantiles, let me simply put describes, because when you use a describe, from there we can actually make, so data frame and describe. So I want 0, 0.05, 0.50, 0.95, and 0.99 comma 1, and this quantiles I want, and dot t, transpose it. Okay, so and all done. The creating the function is done. Now it's time to return the function, return the respective ones. Okay, so now let's uh, call upon so the function has been created. Now it's time to call a function. It's time to call. So function creation is done. Now it's time to call. Let me say d check data frame. Let's check the data frame, and let me give the data frame inside that. And here is that all. You can see the shape of the data set, how big it is, and you got the types of each and every variable. Invoice date is date time 64. Fantastic. Then we have floats, quantity int, and categorical. You got the object. Pretty nice. Then head. So we can see the head of the data set, then tail of the data set, and finding the nones or not availables or null values, then quantiles. So count, mean, standard deviation, min. In addition to that, these four, because we have used the describe method, so we got the total count, we got the mean of the quantity, price, customer ID. Of course we don't require, this is unique number. So for quantity and price, for these two it's useful for us. And you got the quantiles. Basically you got the 5 percentile, 50 percentile, 95 percentile, 99 percentile, and 100 percentile, and the min and maximum values of that. And this is the overall description of our data set, and this is the exploratory data analysis that we have done. Okay, so now let's move. So in the same step we will also be doing. So step 3.1 is preliminary examination is done. So now let's go for 3.2, where we will do the outlier threshold setting or outlier detection. So 3.2 outlier threshold setting. So here let's define outlier underscore thresholds. So let me give the data frame as an as a parameter. then variable is another parameter, then quartile 1 is equal to data frame, and variable, just bring up one variable out of that, and let me say quantile for that, or you can say quantile of 0.01, and same, let's take the quantile 2 data frame and variable, and quantile 2 is 0.99. So in between that I want, and remaining I just want to eliminate as uh, outlier. So I'm gonna go for the quartile inter quantile range underscore range. So let me write down quantile 1 and quantile 3. So the difference between them, that's what I want. So quantile 3 minus quantile 1. So that's what is our IQR interquantile range. So now let me take up limit is equal to quartile quartile 3 plus 1.5 times interquantile range, and let me do it for the lower limit. Only I have to change the sign, low limit, and just put the minus here, and final one, return low limit and up limit, and execute it. So that's it, your function has been defined properly. Okay, now replacing, so outlier detection can be done with this. Now we have to write a function to replace outliers with threshold. So that's what another one we have to write. So for replacing outliers with thresholds, so def replace underscore with thresholds data frame and variable. So low underscore limit and up underscore limit is equal to outlier thresholds and data frame comma variable, and data frame, let me use a location or locating it, and data frame variable less than, if it is less than low limit, if it is less than low limit, if this is less than low limit, so location, if it is less than low limit, and variable is equal to low limit. So let me copy the same one for here, but this time it's variable which is less than, which is greater than up limit, and let me say it as up limit. That's it. Replacing outliers with thresholds also has been defined. Now it's time to uh, apply these or call these functions. Okay, so let me simply say df dot describe and dot t, and here it is. It's been transformed. That's transposed, and this is how normally you're supposed to get. And let me put t to transpose this. Okay, so you got the count, mean, standard deviation, minimum values and maximum, and you got the quartiles. You see that? Okay, so that's what is describing the data. Now it's time to enter into the step 4, which is a feature engineering. Okay, so here what we are going to do is step 4. We will 4.1, which is preparing the ARL data structure. So which is nothing but invoice product matrix. That's what we are going to prepare here. Okay, so let's begin. Let's choose one country. We have chosen a country for the rules of association. So DF, let me say FRA because it's a France. So DF of let me check the country. Country. Yep, is equal to France. Yep, there is some issue. So DF, of course, that's the issue. Yeah, that's it. So now let's see what the df underscore f or data frame consists of. Obviously it's going to consist of only a data with respect to the France. So that's what, because we want to do it for only France, so we have chosen a country for the rules of association, which is a France. Okay, now let's move ahead. Let's group it because we want to make invoice product matrix. Okay, so let's do that. So df underscore France dot group by, we have to use a group by method. And what all I want to group by, so invoice 1 and description. Okay, description. And with what you want to aggregate it, I want to aggregate them using quantity, aggregate using quantity variable. But what do you want to do, which aggregate you want to apply, that's the key value pair we have to provide. So I want to sum it, so that's the reason. And finally just give me the top 30 rows just to see, and this is what we got. So after doing that, so invoice for this invoice, and these are the products that we have, and this is the quantity. Okay, so the summing up, the quantity has been summed up based on invoice and description. Okay, this is what you can see. So that one level of group by is done. Now we just want to unstack the same thing. Let's do that. Let me copy this, exactly the same one. Okay, so now what I'm gonna do is I'm gonna apply unstack method here. So unstack, after the sum, unstack, and then to the index location of 0 to 5 and 0 to 5, and here is your data set. So obviously I have unstacked it, and this is your invoices, and these are the descriptions, various product descriptions: Dolly Girl Breaker, Flamingo Lights, London Mini Backpack, Large Skull Windmill, etc. Okay, so absolutely fine. Now let's move ahead. So now what we are gonna do here is we will we had unstacked it, and we want to fill nuns with zeros. That's what here we are going to do. Whatever nuns we can find out, so those I just want to fill it with zeros, because that's why in data cleaning process we haven't handled the none values or not available values. So that's what we are going to do here. So here I'm going to apply fill NA method, and I'm gonna give 0. Okay, and let me say I log. Okay, we got some issue here, so let me check. We got the unstack, and we applied fill. Okay, fill NA, and that's it. Okay, the data has been, the null values has been replaced with the zeros. Fine, absolutely fine. Now let's move ahead. So let's setting data to 1 and 0 using description. So df underscore fr dot group by, and first one is invoice and second one is description. Okay, and backward slash, let's apply, just a minute, yep, let's apply various function aggregate of quantity, sum, then let me apply unstack again, then apply fill NA, then finally the most important one, apply map. So in this apply and map it. So lambda function I'm gonna use lambda, and anonymous function x1 if x greater than 0, else it's just 0, and finally I lock, and I'm gonna apply the same one, 0 to 5 comma 0 to 5, and here is your response. Okay, let's setting data to 1 and 0 using stock code also. Let's setting data to 1 and 0 using stock code. So let me copy the same code, let me copy this and do the minor modification. That's enough. Okay, so in spite of in description I'm going to change it to stock code, and quantity remains same and rest all remains same. We faced an issue, so saying stock code. Okay, got it. This is capital C, and that's it, it's done, all done with respect to the stock code. Now let's, using a program, let's apply, let's make a function for this so that it would be easy. So using a program, so let's say df define and create invoice product underscore df. So obviously I'm going to give data frame. Data frame is our first uh, parameter, and second parameter is id is false. And let me paste. If id is this, let me return the stock code. Okay, so and if else let me return the other one. So this one I'm gonna return. That's it. I execute it. The function has been defined. Now I can call up. So let us call up. So let's make a new data frame. France invest pro df. Okay, France invoice product data frame. France invoice product data frame. So let me use the method function that we have created and just give df France, and let me print that too. So France invoice product data frame and head 20, and this is what is required for us. Let me put it 20. Yep. And this is what is the data set that we wanted. France invest pro df. Okay, so now let's add according to the id number. So according to id number, so France invest df id is equal to create, and let me add data frame df France, and id is true, and let me print it. France id and head and 20, and this is with according to the id. Okay, let's check the stock code. Let's write a code to check the stock code. Check stock code. So def check underscore id, and obviously first is data frame, then we have the stock underscore code, and now let's write it product. This is, so we can use this check id in later stage to check the id. So we can just give the stock code, and we can find out the product name or product description. So product underscore name is equal, this is very important, so in later stage we can use it. So data frame, and again data frame. So inside that you have to get into the stock code, and so stock underscore code, if that's equal. So let me mention a description. From there you have to get description, and finally values 0, and to list, it's nothing but to list. Okay, just convert that into list, that's it. To list method is nothing but just convert that into list. Okay, so now let's print the product name. Just a minute. Yeah, print product name. That's it. The function has been successfully created. Whenever we want, we can just call it and check it. If you just want to call it and check it, we can do it here only. If name is equal to underscore main, so print check id and from data frame df underscore fr and 10120, and you got it, a doggy rubber. You got that, doggy rubber. Next, let's check the other one. Any 10002. Let's see what we get. It's political inflammable political globe, and that's what we got. Okay, and let's check one more. Let's check few more, not just one more. So print, let me copy this exactly. This time I'm gonna go for 16043, and what we got, it's pop art push down rubber. And next, 20615, 20615, and it's blue spotty passport cover. We got blue spotty passport cover, and this is what we got. Okay, so now ED is done and most of the work has been set. Now it's time for model building. So step 5, model building. So extraction of association rules. So that's what we are going to do. 5.1, extraction of association rules. So this will be to find the support values. That's nothing but the probabilities. That is probabilities of all possible product associations. Okay, so let's begin. Let's call this as a frequent item sets. Okay, frequent underscore item sets. So obviously I need to call up the respective class. So it's nothing but instantiating the class object of a priori. So this is what I'm going to call up. So a priori, so that's what the class object I'm going to instantiate here. So, and what all parameters I have to give. The first thing is data frame. So I'm going to give a France invoice product data frame. Then next keyword pair that I have here is min support. So min support I'm going to give up 0.01, just 1% minimum support. Then use column names. As of course, use them exactly. And let me instantiate this object. And if you want to see what is this type of frequent item sets, it's clearly a data frame, but fundamentally it's an a priori object. Okay, so next, the most important step that we are going to do here is, so the frequent item sets with a priori algorithm, using data frame and min support, everything has been set. Now let's try to view those items. So frequent item sets, and let me sort them. Let me sort those values. And first one is support. That's what I want. And ascending. put ascending a false method, false, because I don't want that, and head I just want to see 20. So now it's time to see the frequent item sets. So let me say frequent item sets dot sort values, and I want to see the support. That's nothing but the probability. So ascending, I don't want the ascending false, and bring up the top 20, and here it is. So 305 got 0.75 support, it's 75 percentage, and the item set is postage. Then 0.21, 0.18, and 0.117 from 0.75. So descending order, so highest to the lowest, and let me call up all, and let's see what will get it, how many, and all in descending order. Oh, 8,175 rows, and those many rules that we have here, because a priori principle or a priori algorithm has created these many rules, and obviously 305 has highest support, and then 0.21, 0.8, 0.17. I have pruned some which is lesser than 0.01. So now let's see. Okay, this is what the overall item sets support that we got here. So now let's move ahead. So let's figure it out. Now let's figure it out rules. Now it's time to make up rules. So rules is equal to, I need to call up the association underscore rules class, and inside that these are the frequent item sets, because we have calculated the item sets, so not rules. Whatever we have seen so far, we have just using a priori principle or a priori algorithm, we can get the frequent item sets. The frequent item sets is nothing but, first in a priori principle we will begin with one item set, then two item set, then three item set, then four item sets, and it will keep on going until it is exhausted. So association rules, now I have to give this item sets, frequent item sets that I have created from the a priori method. So now I'm going to give this to association rule, and that is going to create the association rules between these frequent item sets. So frequent item sets, and what metric I want to use, I'm going to use support metric. Support. Okay, and so min threshold, as I have told you before, 0.01, that's what I'm going to give, and let me execute it. And here is your rules which are made up. So but before we discuss about the rules, I just want you to give you clear cut understanding of some of the terminology, so before we get into that. So that's what we are gonna do. Okay, so first, antecedent. Let's see, rules association rules terminology. Okay, the first one is antecedents. Antecedents is nothing but the first product. If, let me write a rule here, so x tend to y, in that the first product is called antecedent. Let me write it down as x. So antecedents refers antecedents refer to the first product or item in an association rule. So they represent the items that are present on the left hand side of the rule. In simple terms, antecedents are the items that are observed or purchased first. So that's what the best way to put it. So antecedents are these are the items that are observed or purchased first. Okay, so that's what is antecedent for us. Next, what we have here is consequence. Consequence. So this is a second product, basically y, So consequence refer to the second product or item in an association rule. They represent the items that are present on the right hand side of the rule. In other words, consequence are the items that are likely to be observed or purchased after the antecedents, or consequence or the items that are likely to be observed or purchased after the antecedents. So that's why it's called, these are called consequence, because it is a consequential effect of antecedents. Okay, so what's next? So next we have is antecedent support. Antecedent support. Antecedent support is the probability of observing the first product alone. Okay, so antecedent support is the probability of observing the first product or antecedent alone. It represents the frequency or proportion of transactions in which the antecedent item occurs. Then we have the consequent support. It's the probability of observing the second product alone, or it represents the frequency or proportion of transactions in which the consequent item occurs. Then just support. So support is the probability of, it is the probability of both the first and second products. You can say X and Y. First product is X and second product is Y. Products being observed together. So it represents the frequency or proportion of transactions in which the antecedent and consequent items occur together. So then we have the confidence. So confidence measures the probability of purchasing the second product. This is consequent when the first product, which is antecedent in purchase, antecedent is purchased. That's it. It's nothing but your conditional probability is purchased compared to the situation when they are purchased independently. Just a minute. Yeah. So it is calculated by dividing the support of both the antecedent and consequent items by the product of their individual supports. So lift values. So that's what we get it here at the confidence. So confidence indicates the strength of the association or the reliability of the rule. Okay. So what's next? Next, what we have here is a lift. So lift measures how many times more likely the second product is to be purchased. Now let's look into the lift. So lift measures how many times more likely the second product is to be purchased. So lift measures how many times more likely the second product, which is nothing but the consequent, is to be purchased. When the first product is purchased. Okay, compared to the situation when they are purchased independently. So it's calculated by dividing the support of both the antecedent and consequent items. Okay, um, and lift values greater than 1 indicates lift values greater than 1 indicates a positive association between the items. Okay, so now let's move on to the leverage. So once leverage is done, then we'll begin with our coding. Okay, so what's next? What we have here is leverage. So let me understand leverage. So leverage is similar to lift but focuses on the difference between observed co-occurrence of the antecedent and consequent items and the expected co-occurrences if they were independent. So it gives priority to higher support and helps identify the significance of the association. Okay, so leverage similar to lift, but it gives priority to higher support. Then we have conviction. Conviction is expected frequency of antecedents X without consequent Y. And the last one is Jeng's metric. Last one is Jeng's metric. So Jeng's metric, Zhang's metric. So Zhang's metric is a statistical measure used in association rule mining to evaluate interestingness of the rules. So it considers the support, confidence, and lift values of the rules to determine their significance and usefulness. So these metrics provide prior various aspects to assess the strength, reliability, and significance of association rules discovered through association rule mining. Okay, so let me put it in this. Okay, done. So now let's get back to our code. So once you understood this terminology, it's pretty easy to handle. So now let's apply the min support to this. So let's filter out the rules which are significant. So rules, let me add condition rules, and let me take the support from that. Support should be greater than 0.05. I want rules whose support is greater than 0.05, and also I want rules whose confidence is greater than 0.1. This is what I want. And rules with lift greater than 5. So we have some issue. Rules, let me see this. This is the first condition, rules which is greater than. Okay, I have to close this one, and this one is closed, and this one is supposed to close. remove this. Okay, that's it. So we got the data, and but before that I just want to show you uh, rules. Okay, so these many rules, 69,440 rules, and this consists of antecedents, and each rule consists of antecedent, and this is what we call it as an antecedent. Antecedent is product. So here, dolly girl breaker, dolly girl baker, and we got the consequent. You see that consequent, this is what we have defined, and dolly girl children's bowl. Then we have calculated, obviously this is, we haven't calculated the association rules will that object will give all this information. So antecedent support, and then the respective probability of antecedent, and consequent support, a respective probability of consequent, and the support, the probability of getting antecedent and consequent of both together. Then confidence is your conditional probability, like probability of consequent given that antecedents has bought or has purchased. And then we got the lift. A lift is again Bayesian probability kind of thing. Lift measures how many times more likely the second product is to be purchased when the first product is purchased. Then we have leverage, convection, and Jing's and Jang's matrix, Jang's metric, and everything you can see. Total we got the 69,440 rules. So out of these rules, I need to filter out, I need to apply uh, a filter so that I can get rules which are significant. I can get an association rules which are significant. So rules with support greater than 0.05, and rules with confidence greater than 0.1, rules with a lift greater than 5, and I got 64 rules. 64 rules, I got 64 rules, and remaining rules has been deprecated after applying the conditions. And these are the rules, these are the association rules which are significant, which makes significance a significant uh, which makes a significant sense. Okay, so now what we are going to do, we are going to do some checkup. So check id that we have created, that we have defined check id function. So now let me give dff underscore fr and 21086. so this is set forward slash 6 red spotty paper cups. Okay, this is just a paper cups with set, and this set consists of 6. Okay, so now let's apply uh, rules, and one more same rule, but we will put this in, we'll sort that, and we'll put it in ascending descending order, so that we can have a more clarity of which rule has highest. So let me say sort values, sort underscore values, uh, so sort with respect to the confidence, and ascending 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 is false, and here it is. So this one got highest support and highest confidence. Oh, fantastic, 0.97, and you got the good amount of lift and leverage and convection, and that you can see. So total, this are the association rules which have the highest confidence, highest basically highest confidence, and which has been put in descending order from highest confidence to lowest confidence. And these are the final association rules which makes more sense, and from this we have to prepare the script of the study, and then from this association rules we have to create a recommendation engine or recommendation system. So now it's time to move on to the step 6, which is preparing the script of the study. So nothing, whatever we have done so far, because that's like a pre-study, that's like a study. So now let's create as a script, a step by step. So that's it. So we have let's execute this step 6, and we have done the outlier threshold. So that's to detect the outliers. Then we have to replace that outliers or remove the outliers. So that's what replace with thresholds, that's what we did. Then retail data prep. Then after that we have done uh, create invoice product data frame using the grouping by or group by, using a quantity as an aggregate, and submit and apply a respective lambda function. Then we have created a check id function to figure out if id stock code was given to the check id function. It's going to revert back a description of the product. Then we have created the create rules, and finally df, and then this is what the final output we got. We have filtered out the rules based on the significance of it. So support, which is greater than 0.05, confidence greater than 0.01, sorry, greater than 0.1, and lift, which is greater than 5. So the rule, the association rule, which has all these conditions, which has fulfilled all these conditions, can be called as the significant association rule. So that's what we have done so far. So now it's time for it's time to make a recommendation, a real time. Your model is absolutely ready. Now it's time to deploy into the real world, and let's create a real time predictions or real time suggestions or real time recommendations. So step 7, real time recommendations. So 7.1, suggesting products to users at the cart stage. Let's take one product ID. So let's take product underscore ID is equal to 22492. Okay, when the customer purchases this product, which product I should recommend? That's what my question. So first we should understand the name of the product. We should know the description of the product. So for that I'm going to use check ID. So df underscore, let me say product. Okay, okay, capital P, product underscore ID. So this is a mini paint set vintage. Okay, basically this is a paint one. Okay, let's see. So now if customer buys this, so which product I should recommend him? So sorted underscore values, sorry, sorted underscore rules is equal to rules dot sort values, and I'm gonna go for the lift. With respect to the lift and ascending, I don't want it, so I'll make it false. Okay, so now I'm gonna create a recommendation list, which is an empty list. Okay, so then I'm gonna create a for loop. I'm gonna use a for loop for I product, in enumerate. So sorted rules, and where antecedents, main focus is antecedent. So for j in list of product And if j is equal to product id that we have mentioned, then you have to append the respective rules, the respective consequence of respective association rule to the recommendation list, and that's what we are doing. So append a list of sorted rules dot index locating, that's I, and what I want is consequence, okay, capital consequence, still we are not getting, so consequence, okay, so let me put it 0. Okay, so that's it, our loop is ready. Now let's execute it. There is some issue, product id is not okay, I have to give the capital P. So let me give the capital P. That's my mistake. Sorry for that. Yep. So product ID. So our recommendation list is ready. Now it's time to see our recommendation list. So recommendation list, and I'm gonna call up 0, 2, 3 and 21914, 21080, 2. Okay, that's also same one. 21080. So this is what we can basically recommend these products. So now let's create a function to this so that it would be easy to use it repetitively. So that's what I'm going to do. So let's create a function diff arl underscore recommender. I'll call this as a recommender, arl underscore recommender. So rules, this is our first parameter, and then I'll take up the product ID, that's our second parameter. Then I'll say record underscore count, which is equal to 1. So sorted rules, everything, let's okay, sorted rules. So let me simply copy from here, so why to write it again. Then recommendation list, let's take this everything and put it here. And what I want to do is I have to return it, that's it. Okay, that's the issue. Yeah, done. So now let me return this. So return recommendation list from 0 to record count, whatever count it has, not an issue. Expected for statement, okay, an expected indented block after for, okay, got it. There is, okay, okay, then if is going to lose this, then this one is going to lose, that's okay, no issue. So our function is ready. Now it's time to directly apply to this function. So now I want to see if a customer buys this product, so which is mini paint set vintage, so now which product I can recommend, that's what. Okay, let's do that. Let's apply, let's use the function arl recommender. Then first one is rules, let me say rules pd rules, that's what rules is. Rules data frame consists of a significant association rule, so that's what is our first argument. Then our second argument is respective product id, So this is our product ID. Let me give this, which is paint. Now the third one is how many I want. Initially I want one recommendation. So this is what. So what is this? Let me check. So what I can refer. So check ID and DF, and this is 2249. So it's okay. Sorry, I have to give this one. Okay, blue harmonica in box. Okay, it makes some sense. It makes some sense. Okay, next, let's repeat this. Let me go for the 2 now. So 21080. Let me check what it is. And this is red spotty paper napkins. Probably possible. Yes, this also makes some sense. So that's the reason we got it. Okay, and simply if you want to see, this is how you can use ARL recommender, or this is how you can use a priori algorithm and association rules method to basically give a recommendation and give a suggestion products, suggestion to your customers to buy a product. This is heavily used by various retailers or e-commerce companies, and even in their stores. This is very, very useful technique, and this is part of pattern discovery in that supervised machine learning data science process.